Okay, so this video is for Chapter 1, Section 3, part of our Level 1 video notes that you can take. And first thing we can see here is that there are 6 vocabulary terms, and the video is intended to be viewed while having the textbook with you. We have terms such as point, which is considered to be an undefined term. A point is just a location, a point in space, a point on the table, on the board, on the ceiling, anywhere. Space. Well, space is the set of all points. When you put all the different points together, we get a space. Line. Well, a line is a set of infinite points that continue off in 2 directions. We're going to be discussing how we name lines coming up. Collinear. Collinear would be any set of points, whether it be 2, 3, 4, up to infinite points that lie on the same line. Even though there are infinite points on a line, when we look at things that are collinear, we are looking at a finite number. 3 of them, 4 of them, 5 of them. Do they lie on the same line? A plane. Well, a plane is when we would take the line and extend it in 2 dimensions and make a flat surface that extends forever. So for example, this whiteboard here is a plane, but it would extend forever up through the ceiling, down through the floor, left and right through the walls. It's a flat 2-dimensional surface that extends forever. And then coplanar. Now coplanar, we're not just talking about points. It's not just whether these 3 dots are all on a plane or whether or not these 20 dots are all on the whiteboard. Coplanar is any set of points, lines, rays, segments, any single-dimensional figure, whether they lie all on the same plane. So coplanar, points, lines, and segments that lie on the same plane. Alright, so let's get started. First of all, lines. Again, a set of infinite points that extend in 2 directions. Currently we have a line with 2 points defined, A and B. Lines can be named in more than one way. We'll start off with, we could call it line AB. You would read this, line AB. The symbol must have the arrows above the A and the B to show that it extends forever past them. Or we could call it line T. T is a lowercase letter that is at the end of one of the arrows. This is the only way that we name lines with 1 letter. We do not name lines with 3 letters, line ABC, just 2. And we'll learn a little bit more about why later. So here's a line where we can clearly see 3 points. Points R, point S, point T. What is the name of this line? How many different ways could we name the line? This is a question that you could ask yourself and write down. One name could be line RS, which we would write with R and S and put the line symbol above it. So, that's one out of, if you've been working on it, 6 different ways that you could name this line. Here's a question for us. What is the difference between naming the line RS or line SR? We're so used to, in English, reading things from left to right, we think this one looks kind of weird. But technically speaking, lines can go up, they can go down, they could go straight at the camera. So therefore, what order we put the 2 points doesn't matter. It still describes all the points that go from R to S and extend it on. The answer is, there is no difference. Okay? Directions, they both go in 2 directions, so it can't go opposites. They start and end at different points. Lines don't start, they don't end. No difference. Okay, so we go to the term plane, the flat 2-dimensional figure that extends in all directions. Well, they can be named in 2 different ways. If we name it with 1 single letter, like plane P, the capital letter should have no point to it. This can be a little confusing later when we get into 3-dimensional shapes, but for the most part, it's understood to be in the upper right corner. Or, the most common way to name a plane is with 3 non-collinear points, A, B, C. These points cannot be connected with 1 straight line, so they would then form a triangle. Well, a triangle is a flat 2-dimensional shape, so it forms a plane. A, B, and C describe this flat green parallelogram surface that then extends beyond. So why 3 collinear or non-collinear points? Why 3 non-collinear points? Well, try to answer this question real fast. How many planes do the points S, A, and T land on? Here's a red plane, it's kind of like a piece of paper, and there's another piece of paper that's gray going this way. Here are the points S, A, and T. Well, how many points do those 3 points lie on? Do they lay on the red plane? Do they lay on the gray plane? Are there more that we can't see? Well, the correct answer here is infinite. They lay on infinite planes. There's another plane that could go straight through like this piece of paper would be and hit all 3 of those points. So the problem becomes, if I was to say, hey everybody, look at plane SAT. Which one? No one would know. So that is why a plane must be named with 3 non-collinear points, because the instant they form a triangle, there's no other plane that can hit them. Let's try this. 1, 2, 3. Those 3 points are all on the whiteboard. Here's my other plane. I wonder, can I make this hit all 3 of those points without lying flat on the whiteboard? I can hit these 2, maybe these 2. I really can't hit all 3 unless I make the exact same flat surface. So, keep in mind, every point on the line TS is on the red and gray plane. Therefore, a really important fact right now is that collinear points lie on infinite different planes. 1, 2, 3, so many. So plane SAT could be the red or the gray. We do not name a plane with 3 collinear points. It needs to be non-collinear and make a triangle. Alright, now here's more than 3 points. For example, in this 3-dimensional figure, if you can see that, ABFE would be an example of coplanar. They are the front of the cube. ABFH would be an example of not coplanar. ABF, these 3 form the front, and then H is on the back, not coplanar. I guess you could look at A, B, and H and see a diagonal ramp that goes from A, B, H, and G, and then you would say F is the one that's not coplanar. Technically speaking, any 3 points, BFH, those are coplanar. That's the diagonal going this way. ABF, sure, that's the front. Well, what did we try? A, B, and H without F? That worked too. So it's not one point that's not coplanar, it's the set of those 4 just don't work well together. Then there's D, B, and G. D, B, G. First thought is that those are not coplanar, but they are only 3 points. And they make a triangle. They have to be coplanar. They make a flat surface. If I took a roll of paper from D and B and rolled it up to G, I could make a nice ramp. Therefore, they are coplanar. That ramp would be a flat 2-dimensional surface. So, why are any 3 points always coplanar? Well, there's only 2 options. Either 3 points are collinear, and if they're collinear, they lay on infinite planes. 1, 2, 3. Those 3 points lie on the whiteboard, but these 3 points also lie on the plane going straight through here. So 3 points, definitely coplanar. If the 3 points are not collinear, well then they form a triangle and they are coplanar. So no matter what, 3 points, always coplanar. 4 points, sometimes. Sometimes they are, sometimes they're not. 3 points either collinear or not. If they form a triangle, then they make a plane. That was the answer we just came up with. Next up, we're going to talk about a few basic postulates to end this lesson. Postulate means an accepted statement of fact. You may want to write down that the word axiom, A-X-I-O-M, is the exact same word. It's an accepted statement of fact. These things don't need to be proven to us. We just generally understand they're true. 1. Through any 2 points, there is exactly one line. Point AB, line T is the only one that goes through them. Think about connect the dots. The picture doesn't change every time. You connect 2 points with one line. 2. If 2 lines intersect, they intersect at exactly 1 point. Well, if 2 lines intersect and then go on forever, they don't come back around and intersect a second time. Now again, this is in Euclidean geometry where we're talking about planes, not spheres like the Earth. Just on a flat surface, if 2 things intersect, it will only happen once. Now, if 2 planes intersect, they form a line. Think of when 2 walls come together. They form a corner in a room. That corner line, that's the intersection of the front wall and the side wall, or the ceiling and the roof. Line ST is the intersection of the red plane and the gray plane. 2 planes do not intersect in a point. 2 planes, if they intersect, will always intersect in a line. Postulate number 4, the last one. Through any 3 non-collinear points, there is exactly one plane. What did we say about non-collinear points? They form a triangle. If you have a triangle, that becomes a flat surface. Not a bunch of flat surfaces, one specific flat surface. So any 3 non-collinear points will guarantee you one flat surface. Kind of like a tripod, which I'm using to video this. Tripods put down 3 legs. No matter how unlevel the ground you're going to, once you put those 3 points down, it is stable. That is because those 3 points are now creating one flat surface for the tripod. Here's a quiz that you can look at. You can pause the screen now. We will be going over this quiz in class, so I will not be talking about the answers. Again, feel free to pause it, look at this, think of your answers, and be prepared for when we talk about this in class. That was chapter 1, section 3. Hope you took some good notes.